Welcome to this explainer. Okay, let's dive right in. Today we are taking a pretty incredible journey. We're going all the way from a basic, abstract thought right down to working, functional computer software. Seriously, if you've ever stared at a complex app and thought, how on earth do programmers actually build this? Well, you're absolutely in the right place. We're going to decode the secret language of software development, specifically something called object-oriented programming. And honestly, it is way more intuitive than you might think.
But before we get lost in the technical weeds, I want you to just pause and think about your daily digital life for a second. Think about all those apps you open on your phone or your laptop, day in and day out. What do all the apps you use actually have in common?
Well, the answer is beautifully simple. They all solve problems. Whether you're using WhatsApp to text your family, Uber to grab a ride, your banking app to transfer money, or a library system to manage your reading list, these aren't just random lines of code. Right? They're tools. They are tools specifically designed to help you, the user, get a task done easily and efficiently. At the end of the day, software is really just a collection of programs built to solve real-world problems.
So how do we actually build these problem-solving tools? Well, here is our roadmap for today's explainer. First, we'll look at designing software solutions. Second, deconstructing the user story. Third, we'll explore the class blueprint. Fourth, translating to Java code. And finally, number 5, objects in memory. Basically, we're going to take a really simple idea and turn it into running Java code step by step. And don't worry, we're doing this with zero confusing jargon.
All right, let's kick things off with Section 1, Designing Software Solutions.
You know, the biggest misconception about programming is that it starts at a keyboard. It totally doesn't. The most crucial work actually happens long before a single line of code is ever typed. Before we write anything, we absolutely have to understand the problem we're trying to solve. And we do this using something called a user story. A user story is just a short, plain English description of a feature, written completely from the user's perspective. It tells us who the user is, what they want, and most importantly, why they want it. It keeps our focus totally locked on the user and the value we're providing them. That way, we ensure we're actually building the right software for the right people.
Let's look at a concrete example to guide us through this. Imagine we're building a library management system. A classic user story for this would be something like, as a library member, I want to borrow a book so that I can read it at home. That's our little micro-narrative. It's just an everyday sentence. But how on earth do we take that simple sentence and turn it into a complex digital system?
That brings us to Section 2, Deconstructing the User Story.
This is where the magic really begins. We're going to break down that plain English sentence into raw programming materials. And honestly, this right here reveals the biggest aha moment in object-oriented programming. Are you ready for the secret? Object-oriented programming is literally just mapping elementary school grammar to code concepts. Now seriously, it is. The nouns in our story, those become our objects, like a book or a member. The verbs become our methods, actions like borrow or return. And the descriptive information? That becomes our properties, like a title or a name.
Let's see how this builds up step by step. Step 1 is identifying the nouns. If we look back at our story, the important things are the library member and the book. We can also spot some implied nouns, right? Like a borrowing record or the date. Good software design always starts with understanding these fundamental things, because in this style of programming, nouns usually become our objects, and objects simply represents a real-world entity inside our digital system.
Okay, moving to step 2, identify the verbs. What actions are actually happening? Well, our member wants to borrow a book. Eventually, they'll need to return it. Maybe they search for a book, or the system needs to check availability. Spotting these verbs tells us what our objects are actually going to do. In the programming world, these verbs become our methods. Methods are simply the actions or the operations that our objects can perform.
And then step 3, identify information. What does each object need to remember about itself? A book object, for instance, needs to know its title, its author, its ISBN, and maybe if it's currently available. A member object needs to remember its member ID, its name, and its email. Objects hold on to this information using properties, which you might sometimes hear called attributes. So to quickly recap where we are, an object represents a real-world thing. It is packed with its own data, its properties, and it has its own actions, its methods. We have gathered all our scattered raw materials, our nouns, verbs, and properties. Now we just need to organize them.
Which perfectly tees up Section 3, the class blueprint.
This right here is probably the single most important visual analogy you can grasp in software design. The difference between a class and an object. I want you to think of a class exactly like an architectural house plan. It's a blueprint on a piece of paper. Now, you can't live inside a house plan, right? But from that one single blueprint, a construction crew can build dozens of actual physical houses in the real world. The blueprint is the class. The actual physical house sitting on the street, that is the object.
Just to really cement this in our minds, the class is the blueprint. It defines the general structure, the rules, what properties are going to exist, and what methods can be used. The object, on the other hand, is the real thing. It is an actual living instance that was created from that class blueprint, but it's populated with its own specific data. So there is only one abstract book class, but there can be millions of unique book objects living inside your library system.
And because a class is essentially a blueprint, we can literally draw it out. We do this using a simple class diagram. If you look at this box representing our book class, notice how it's divided. The upper section lists out the properties: title, author, ISBN, availability. This part stores the state. Then the lower section lists the methods: borrow, return book, display details. This part defines the behavior. The class is just this master template that glues the data and the actions together into one neat, cohesive unit.
Let's move right along to Section 4, Translating to Java Code.
Now that we have this perfectly logical blueprint mapped out, it is time to actually write some code. And hey, if you have never coded a day in your life, do not panic because you already know exactly what this is going to say. Let's break down the anatomy of Java code. It mirrors our diagram perfectly. First up, we declare the class name, which establishes our blueprint. Next, we list out our properties right near the top, telling the system exactly what data it needs to store. And finally, we define our methods down below to spell out exactly how the actions are executed. It is a literal one-to-one translation.
Take a look at this snippet of Java code. Right at the top, we say class book. Then just below that, you'll see string title and string author. Boom, those are our properties. Drop down a bit further, and we have void borrow. That's our method. When that borrow method runs, it changes the availability property to false because the book is checked out, and it prints a little message. We quite literally just took our grammar exercise from earlier, our nouns, verbs, and properties, and typed them into Java syntax. That is it.
All right, the final piece of the puzzle. Section 5, Objects in Memory.
So we wrote our blueprint in code, but like we said earlier, a blueprint is basically just a piece of paper. We still need to build the houses. We need to make this abstract code come alive inside the computer. Check out that line of code. Book, Java book, equals new book. See that little word new? It is incredibly powerful. It basically acts like a construction crew. When you run your program and the computer hits that keyword new, it goes straight into the computer's memory, carves out a physical space, and constructs a brand new, real object based on your book blueprint. And once it's created, we can give it specific property values, like setting the title to Java programming, and we can start triggering its methods.
The real trick here is visualizing how this actually looks inside the computer's memory, which programmers call the heap. Think of it kind of like a neighborhood. From our one single book class blueprint, we use that new keyword to create object 1, which we titled Java Programming. Then we use it again to create object 2, titled Database Systems. One single class creates multiple, completely independent objects. Each object gets its own cozy space in memory, and each has its own unique state and values, even though they were both built from the exact same structural blueprint.
And just like that, we have gone all the way from a plain English user story to running Java objects living right inside a computer's memory. You have officially learned the foundational process of object-oriented programming. So, knowing this secret translation process, I want you to look around you today. Think about the apps you love: Spotify, Amazon, your favorite video game. What are the nouns? What are the verbs? How would you design the everyday software systems around you now that you can actually see the blueprint beneath the code? Think about it. Thank you so much for exploring this fascinating topic with me on this explainer. Keep learning, and I will catch you next time.